Good day, everyone. This is Keith speaking. I'm going to introduce you to our final year project titled Development of an Effective Classification Technique to Classify Settlements to Various Land Cover Features. Although India is one of the less urbanized countries of the world, with only 27.78% of the population living in urban towns, this country is facing a serious crisis of urban growth at present time. Whereas urbanization has been an instrument of economic, social, and political progress, it has led to serious socio-economic problems. The sheer magnitude of urban population, haphazard and unplanned growth of urban areas, and a desperate lack of infrastructure are the main cases of such a situation. The rapid growth of urban population, both natural and through migration, has put heavy pressure on public utilities like housing, sanitation, transport, water, electricity, health, education, and so on. Urban planning is a valuable force for city leaders to achieve sustainable development. It is a means to bring about a difference. It involves the arrangement and design of buildings, public spaces, transport systems, services, and amenities. It is the process of giving form, shape, and character to a group of buildings, to whole neighborhoods, and a city. It is a framework on which society can thrive. In the field of urban planning, there is a necessity for survey and analysis of large areas in order to understand the problems and possibilities in those areas. The current methods of surveying large areas of land are extremely time consuming and costly and quite difficult. We set out to create a decision support system that can help in urban planning. In order to make the process of surveying easier, we began by using remote sensing.
Hi everyone, I'm Shivam here. For the purpose of urban classification, we needed to survey a large amount of data with minimum on-field work, and the science of remote sensing was best suited for this purpose. What is remote sensing? So, remote sensing is the art of acquiring information about the Earth's surface without actually being in contact with it. The advantages that sensing technology offered include large area coverage. Remote sensing allows coverage of very large areas, which enables the identification of extremely large features. Secondly, remote sensing allows repetitive coverage, which is useful when collecting data on dynamic features such as agricultural land, oceans, and urban land. Remotely sensed data can easily be processed, analyzed fast using a computer. Thus, remote sensing was best suited solution to proceed with our project.
Hi, this is Sherwin. Now that we have established why we make use of remote sensing for urban planning, let me show you our progress in terms of the results we obtained. At an initial stage, we worked on classifying an AIRSA dataset of the city of San Francisco to classify it into three classes, namely settlements, vegetation, and water bodies. In order to create the decision support system, we were in need of a classifier. As a result, we worked with different data forms of the dataset available at hand, combined with various training models such as binary decision trees, random forest, and artificial neural network in order to obtain a highly accurate classifier. Comparing the obtained models, the model with the highest accuracy was then picked. Here is a demonstration of what we have achieved so far. At the beginning, users are allowed to set the number of classes along with how many training samples are needed per class. The user is then required to select the training areas. After the training process is complete, classified images are obtained along with their respective confusion matrices. This can be used to determine the most accurate model among the lot.